Hello and welcome to my talk, Automating APIs in a Highly Compliant Ecosystem. I'm Santiago Gomez. I'm the technical product owner of an API platform that is offered worldwide in Volkswagen Financial Services. So one of the main challenges that we have in enterprises nowadays is that we want to maximize the development speed and the releases of APIs while we still need to cope with a lot of compliant challenges because essentially we are in a highly regulated ecosystem. So first, I want to tell you a little bit more about who we are. In Volkswagen Financial Services, we are the financial backbone for the Volkswagen Group. We started approximately 5-6 years ago with a digital program that aimed at digitalizing our business processes towards our customers. That means that most of the time our customers, they were going to the dealers. They were selecting a car, a Volkswagen, Audi, Skoda, Saez, or even Cupra, and they were leasing or getting a financing for the car on paper in order to get that car out of the dealer and use it. Now, that's the traditional way, and we started 5-6 years ago with digitalizing how that actually happens. That means that bringing the customer data into the center of the equation so that most of those contracts, they can be sold online. We can gather customer data, and we can also provide different types of assessments to the customer. For example, you should have an SUV, or you should have a very small vehicle, or you should even have an electric vehicle. Now, all this has been done for one purpose of trying to sell as many contracts as possible online worldwide. That meant that we essentially needed to scale. So for us, scaling doesn't really mean increasing the amount of customers or increasing the load in the system. For us, scaling meant at that point in time that we really need to bring to the customers worldwide as many applications as possible so that we can increase basically the leads, and we can also increase the adoption of our customer journeys, our digital customer journeys with our end customers. So having that way of scaling or those scaling requirements, that really required us to look at how we are building technology. And more specifically, it required us to look at how we are standardizing. We standardize different layers of our architecture. The infrastructure layer, we standardize essentially where we are running our workloads. So we run our digital workloads on top of Amazon Web Services. We standardize how we are providing data within the organization, aka data lakes, for example. We standardize how we are building APIs, the tooling, the platform, how we are sharing APIs within the organization. And last but not least, we standardize also how we are developing frontends. Now, the whole development cycle of any kind of software in the company, of course, needed to be backed up by standard tools. For example, Concourse for CI/CD, JFrog for being able to store artifacts, GitHub for the source code repository, and Datadog for monitoring and logging. So since we are in the API days, I will focus now on the API layer and tell you the story of how we have standardized, how we are developing APIs in our highly compliant ecosystem. So we have built our standards following the following 4 pillars. First things first, we defined our delivery model of our platform. So we are offering an API, a managed API platform as a service on top of AWS. We have a team, a platform team that is managing and operating the API platform and offering to other engineering teams core components like API gateway, developer portal, etc., etc. We have standardized and automated how APIs are built inside our organization. But for that, we really needed to provide also a tool chain to the engineering team so that the engineering teams, they don't really need to develop tools or develop frameworks around APIs. They just need to focus on developing the API itself. And last but not least, we have really scoped down and defined that our customers inside this platform team are API engineering teams inside VWFS. So let's look now on how our platform, the general level architecture of our platform looks like. I was mentioning before that we are running on top of Amazon Web Services. And Amazon Web Services offers the possibility to have a very, very high distributed ecosystem. And that is towards one main goal, which is minimizing the blasting radius. That means that the one API owner should not have access to another API owner's infrastructure, and any of them should have access to the core components of the platform. And with this, we were really able to offer a highly distributed ecosystem where we are minimizing the blasting radius, where we have a central account where we have the core components of the platform, like API gateway, API portal, platform APIs. And then for each and every product, each and every project, each and every team that is building APIs, they have their own AWS ecosystem where they can deploy those APIs. And we are magically doing the routing. So having these 4 pillars that I was mentioning before, together with this deployment model, really help us to go from 0 to 140 APIs in a matter of 1.5 years. And those APIs, they are distributed in more than 100 AWS accounts. And our API platform is running in 6 regions. It's running in Europe, in Frankfurt, it's running in Sydney, Australia, in Japan, in the US, in Sao Paulo, and there are some more regions coming up. And nowadays, we are handling more than 500 million API requests per month. So how does our API lifecycle look like? As I was saying before, we standardize how we are developing APIs. And for each and every step in the lifecycle, we are providing either a state-of-the-art tool or standard, or we have developed in-house a way of how to support it, basically. So when it comes to the design phase, we follow always an API-first approach. And that means that each and every API must start with a design requirements and then to the design of the Open API specification. In order to facilitate that specification of an Open API document, we also created a so-called API dictionary, which is basically consolidating a standard way of defining API models, especially for fields. Like, for instance, how do you define a customer? First name, last name, which is a description of that, which is the type of that. So we really standardized that part, and we provided an API dictionary. So as I was saying before, everything starts with an Open API. Open API is a very rich specification that can be used not only for specifying APIs, but also for generating any kind of artifacts afterwards. I will show it to you in a second. When it comes to the dictionary, we also provided in our portal the visualization for that. We have a governance model on top of the dictionary where we are doing reviews, where we are ensuring the quality of the content of the dictionary, because each and every field in our dictionary must contain the name, must contain the type, must contain a well-defined description that can be understood by everybody. For the purposes of enabling other teams to define that API document, we also provided the visualization of an API dictionary. So an API dictionary has a governance process on top where we are ensuring the quality of each and every field. That means that each and every field, they must contain a name, they must contain a valid description that can be understood by both technical and non-technical people. It must be typed, and it also must provide an example. In order for engineers to be able to leverage that API dictionary during the definition of an API, we have even developed an extension for VS Code so that the specific fields can be imported in the Open API specification. Now, once we have an Open API specification, it's time to generate a microservice, to generate an executable way of running that API. And we provide it by two generation tools that we have in-house developed. One is called Sirius, that is generating a .NET, and the other one is called Albus, that is generating a Node.js application. So we always start with an open API. Let's assume that we have an open API specification, and now we will run the tool, and that tool will basically generate the project. It will generate the microservice with a lot of different aspects. Like, for example, documentation, risk log, README, change log. It will also generate the main code. It will essentially generate the skeleton for an engineer so that he or she can develop the business logic inside the API. Now, one of the main advantages that we develop in our tool is that we have specific endpoints in each and every API that we have standardized for retrieving API information. For instance, we are providing a change log for the API and the corresponding endpoint, a risk log for the API, and therefore a corresponding endpoint, and even a health endpoint for monitoring purposes. Now, the Open API, as I specified before, is a very rich specification. By having a well-defined Open API, that really helps us also to be able to generate different type of tests. For example, API tests or performance tests. What you are seeing here is one of the features of the tools that we have developed in-house, that apart from generating the code itself, it's also generating already API tests. So for each and every API endpoint, it's generating a happy path and an unhappy path, because we have those examples information inside the Open API specification. So let's wrap up what we are doing when we are generating a microservice. When generating a microservice, our tooling is creating the project structure, essentially the Git project together with who's the owner of the API, and so on and so forth. Documentation templates, technical docs, API docs, risk log, and change log. It's also generating API tests, also the server skeleton, the Express or the .NET server, so that the API engineers can just jump and implement the business logic inside. All the models are, of course, typed and generated by our tool. Standard API endpoints, remember, like the health endpoint, because we need to be able to ensure that each and every API is up and running, and that we are able to monitor that API is up and running. And we are also generating performance tests, skeleton. Now, the next step is the implementation. Once the microservice is generated, it's the responsibility of the API engineer to go ahead and implement the logic of the API. We have the skeleton in place. They just need to go to the necessary files and extend and implement the business logic. For example, mapping, connecting to a downstream service, and so on and so forth. So once the implementation is there, there is an API that is running locally, and now it's time basically to publish it and to deploy it in an ecosystem where it can be accessed by others. So we have two steps with one tool that is essentially providing the orchestration of the steps to have that API up and running in an AWS environment. So during the deploy and the publish step, we have a tool that is called Hybrid that is essentially building the necessary resources in AWS, ECS container, the Docker image, and so on and so forth. And then is interacting with the Kong API gateway so that that API is being published in our platform. So let's go into details. In order to be able to deploy that API, the first thing that we need to have is a CI/CD pipeline, a continuous integration, continuous delivery pipeline. So our tool is essentially generating a standard pipeline that has a standard way of handling that deployment based on the different stages that we have and based on the different steps that we are taking for deploying an API in each and every stage. Now, When it comes to the deployment, I was sharing with you before that we have a highly distributed ecosystem. That means that the API is going to be deployed in an AWS environment that is completely isolated from the core components of the platform, like the API gateway. And that's why there is a necessity for creating this network connection between the two AWS accounts. And this is something that our tooling is doing under the hood. Apart from that, our tooling is also ensuring that the resources that are deployed and provisioned in AWS are done in a compliant way. That means for storage resources, we are really ensuring that there is encryption at rest. For communication